Ball trajectory is a vital aspect of table tennis. Some works have tried to utilize the information to do analysis, and one of them is ball spin analysis. In table tennis ball spin analysis, ball trajectory helps in estimating higher spin rates of a ball by observing 3D calibrated trajectory with simulated physical models to infer the most plausible spin rate. Other than spin analysis, another aspect of table tennis analysis is stroke recognition. This system, TactiPing, uses players within bounding boxes as inputs for stroke action recognition. The ball trajectory is used for defining the temporal boundaries of each stroke. After obtaining the stroke action clips, they will be classified using an RGB model through a three-stage hierarchical stroke classification. But there's a limitation as the system faces difficulties in classifying stroke categories within group F7 and B7. As you can see before, we see that the stroke action within their groups are visually very similar. Motivated by this limitation, we want to see if ball trajectory can be used to improve the intergroup F7 and B7 classification. The proposed method uses the action clips generated by TactiPing. Overall, the action clips will turn into stroke data, and then through pre-processing and normalization, we'll have its feature extracted for classification. So firstly, the ball in the stroke clip will be detected using a YOLO model within the region of interest drawn by this blue outline. For illustration, extracted ball position will be turned into a stroke data visualized on this graph. And then the stroke data went through a data pre-processing. The first one is cubic interpolation to fill out the missing points to make a smooth curve, and then a trajectory segmentation to get the trajectory of an actual stroke. And my contribution is here, cubic interpolation. And then the trajectory data is go through the data normalization, which is a translation and mirroring. After the normalization, its features, which consist of mean speed, max to mean ratio, and so on, will be extracted so that for the information for KN model. And for the experiments, we compare the performance of our method with that of TactiPing. There will be 3 experiments for the intragroup classification of forehand only and backhand only, and we'll use a match video for the testing data. Here's the training set for the model, and here's for the testing set. And here's the result for the intragroup for F7 forehand and for the backhand. And we see that our method excels in both experiments. This shows that ball trajectory can do more than just determining the temporal boundaries of strokes. Same as the ball spin analysis, the ball trajectory can also improve stroke classification. However, the limitation of this experiment is that due to the dataset limitation, because in here there's no dataset for attack and slam, we can't truly know the capability of this model. So in conclusion, the ball trajectory provides additional discriminatory power that visual-only approaches often miss. Even though the accuracy of the current method is still generally limited, the result indicate that ball trajectory information is a promising complementary cue. With more balanced dataset, expanded feature design, and deep learning implementation, trajectory-based classification has strong potential to further improve stroke classification accuracy. Thank you.